In today's tutorial, we are going to explore all the parts of a circle: chord, arc, sector, segment, and tangent, so you will understand geometry like a pro. Let us start with chord. Chord. A chord is a straight line that connects two points on the circle. If this is our circle, this line that connects two points on this circle is a chord. And let us assume that this is our center. The longest chord is called the diameter, which passes through the center of the circle. Chords of the same length are always equidistant from the center. What I'm saying is this: if our circle is this, and we have a chord here, we have another chord here, and this is our center. If the length of this line is equal to the length of this line, the distance from the center to this chord is the same as distance from this center to this chord also. Let us consider this example. A circle has a radius of 5 cm. If a chord is 6 cm long, calculate the distance from the center to the chord. Let us represent the given question diagrammatically. This is our circle. This is our center. This is our chord. From the center to this point is our radius. From the center also to this point is our radius. And the radius is given to be 5 cm. Here also is 5 cm. The question asks us to find a distance from this center to this chord. Let us label the distance D. Let us label this point A, this point B, and this point O. And the formula that we can use to calculate D can be expressed as D equal to square root R square minus bracket AB over 2 square. Our R is the diameter of the circle. Our AB is the length of the chord, and it is given in the question as 6 cm. So let us plug in our values into this equation. D equal to square root 5 square minus bracket 6 over 2 square. D equal to square root 5 square is 25 minus 6 over 2 will give us 3, and 3 raised to power 2 will give us 9. 25 minus 9 is 16, so equal to root 16. And square root 16 will give us 4. So our D equal to 4 centimeter. So the perpendicular distance from the center to the chord is 4 centimeter. An arc is just a part of a circle circumference. Let us consider this circle. Let us draw a chord. Let us label this point A, this point B. From this point to this point is also our arc, but it is called minor arc because of a short distance. Also from this point, like this to this point, it is called a major arc because of a long distance. We write an arc as AB. Arc length formula: arc length equal to theta over 360 multiplied by 2 pi r. This theta is the angle at the center, and r is the radius of the circle. Let us consider this example. If the central angle is 60 degrees and the radius is 6 centimeter, find the arc length. Our arc length equal to theta over 360 degree multiplied by 2 pi r. Here our r is 6 centimeter, our theta is 60 degree. Let us substitute those values into this equation. We are going to have 60 degree over 360 degree multiplied by 2 times pi times 6. 60 here, 1. 60 in 360, we have 6. 6 here, 1. 6 here, 1. And our answer is going to be 2 pi centimeter. That is our arc length. Sector. A sector is a slice of a circle enclosed by 2 radii and the arc between them. Think of a pizza slice. Let us consider this circle. Let us say this is our center. This is the radius. This is also a radius. This shaded point is also our sector. An area of a sector equal to theta over 360 degree multiplied by pi r square, where our r is the radius of the circle and theta is the central angle. Angle at this point is our theta. Let us consider this example. Let us say in a question, it is given to us that radius is 6 centimeter and the central angle, which is theta, equal to 60 degree, and they ask us to find the area of a sector. And formula for calculating area of a sector is this. Let us just substitute our values into this formula. So equal to 60 degree over 360 degree multiplied by 5 multiplied by 6 raised to power 2. 60 here 1, 60 here 6, and we can rewrite it as 1 over 6 multiplied by 5 multiplied by 36, because 6 raised to power 2 is 36. 6 here 1, 6 here 6, and pi multiplied by 6, we are going to get 6 pi. 6 pi centimeter square. So the area of our sector is 6 pi centimeter square. Segment. A segment is the region between a chord and its corresponding arc. Let us consider this circle. Let us draw a chord. Let us label it A, B. This shaded part is our segment, and it is called minor segment because of smaller area. And this also is our major segment because of larger area. And area of a segment equal to sector area minus triangle area. Let us draw this for better understanding. This is our center, our radius. This is our chord. This shaded portion is our segment. Here is R, here is R. This is our center. Let us label this place O, this place A, this place B. You will see from the diagram that our sector is from O like this, back to O. Our triangle is O, A, B. So area of a segment is area of a sector minus area of a triangle. Let us consider this example in which the radius is given to be 6 centimeter and the central angle is given to be 60 degree, which is our theta, and they ask us to find the segment area. First, let us find the sector area, and sector area equal to theta over 360 degree multiplied by pi r square, which is equal to our theta here is 60 degree, so 60 degree over 360 degree multiplied by pi multiplied by our radius is 6 centimeter, 6 square. 60 here 1, 60 here 6. Here also 6, this one means 6 times 6, so 1 6 here We cancel 1 6 there. So our answer is going to be 65 centimeter square. Let us calculate the triangle area. Triangle area equal to half r square sine theta, which equal to 1/2 multiplied by 6 square sine 60 degree, which equal to 1/2 multiplied by 36 multiplied by root 3/2. 2 here 1, 2 here 18, 2 here 1, 2 in 18 9. So our answer is 9 root 3 centimeter square. Segment area equal to sector area minus triangle area, which equal to our area of sector is 6 pi minus 9 root 3 everything centimeter square, or approximately 3.26 centimeter square. That is our answer. Let us move to tangent. A tangent is a straight line that touches the circle at exactly one point, and the point of contact is called tangency. Let us consider this circle. Let us say this is our center, this is our radius. Let us draw a line that touches the circle at a point like this. Let us label this point P and this point 2A, and the angle between the radius and the tangent must be 90 degrees. Two tangents drawn from the same external point are equal in length. Let us draw another tangent that is from this external point. This is our radius. This is 90 degrees, and let us label this place B, and our line BP line is equal to line AP. Let us try this practice question. So now you know 5 main parts of a cycle: chord, arc, sector, segment, and tangent. Next, we move on to a circle theorems, where we'll see how these parts interact and solve tricky geometric problems. If this video helped, like, subscribe, and share. And don't forget to hit the bell icon to catch the next lesson in our circles playlist. See you soon.